Hi all. In this video, let's try to understand the memoization in JavaScript. How does it works? Memoization is a technique where it will return the value if the same input comes. So instead of running the function again, it will return the value from the cache if we get the same input. So that's about memoization. So let's take that with an example. So I will be taking an simple addition function. So don't think that for this small addition function we are trying to do this much of mechanism. So here my agenda is just to make sure that you are understanding this memoization technique, how we are going to implement this. So you can use this technique for the further big functions where you can have a large number of computation tasks. You can use that. So now here I'm using an addition function. So where I will be sending two parameters a and b. So it returns the addition of the two numbers. So here the concept of this memoization is like uh, I will be calling this with 10 comma 20. What happens? So this function calls and this computation will work and it is going to return 30. So again in a program after few lines, again if you're trying to call the same function with the same input, again the computation of this function does here, so which is not correct. So now if you're sending same set of inputs again to the same function, so here we need to get this data from the cache. It needs to return the value 30, but the function should not be executed. We need to return this from the cache. So how we are going to achieve this with the memoization in JavaScript concept. So that is what we are going to discuss. So here we will be calling this once. So it will be executing here with 30. And later on, if you are sending the same set of input, we'll be getting that 30 from the cache. So how we are going to create that method or the functionality. So for that, I will be taking a constant. I will name this as memoize. So here, this is a function which will do all this mechanism. So this function, I will write these comments as well. This function will decide whether to call the function or to return the value from the cache. So this is the function is going to decide whether to call the addition function or not. So that's the main goal here. So for that, we need to pass the reference of the addition function so that it can decide whether to call this function or not. So that's the reason we wrote we need to send the addition function to this memorize function. So in short, this is an higher order function where a function is uh, passing parameter to the other function. So we can say in that case, yeah. And coming to, we need to store the data in a cache. So I'm taking an object like memorize cache here. So I'm taking this object. So what does this object will consist of? So in this object, we'll try to save. So usually object consists of a key value. So we're trying to save the key as the input. Like we'll save addition, a delimiter 10, 20. We'll keep this as a key and the 30, I mean the result as a value. So why I have constructed the key in this way? Because this is a function name, a delimiter. You can use any of the delimiter. Here I'm using a pipe symbol and the parameters 10, 20. So function name with two parameters. I have created this property so that it should be unique. The property should be unique and the result would be stored in as a value. So in this way, this object will have a list of key value pairs where in future, if it gets a key like this, it will directly return the value 30. It will not do any computation. So that's the reason we need to construct this memory cache in that way. So let's start with that. So when we call this memorize function, it should return a function. So I'm trying to return a function from here. These are the arguments which we are sending. I mean, in our case, it would be like 10, 20. So this function, this function should decide whether the value is present in the memo cache. If it is present, if it is not present, we wrote not present. So if it is not present, so then call the function and do computation. So what all the logic we need to do? We need to do that. If the value is not present in the memory, if it is present in the memory, just return that value, just log that value, because you have that value in your memory. So just log that value. So that's the main thing. This is what we are going to do here. So let's start and do that. So for that, I will call like another function like memorize addition is equal to, I need to memorize this. I'm calling this function with addition as a parameter. So I'm passing the function reference here. So where in this case, I need to call this memorization in this way. I will do a console. Let's check this. So the same console I'm using here as well. So, so travel with me for some time. So I will try to make sure you understand this. So here I'm calling this function because this function will decide whether we need to call this addition or not. In this function, we will be having a memory, I mean an object which stores the cache and will decide whether to call the function or not. If there is no need to call the function, we'll be returning the value from the cache. It means the value already present in the cache. It means we are sending the same parameters. So let's discuss. I will be using all the different inputs as well. So let's start that. So now we are calling this memorize function and passing this addition, and we have created this. So here we need to construct the key. Every time we need to construct this type of key because the key should be unique. In that way we can decide the this for this unique key we are storing the unique value of result. So for that we need to create the property as a unique. So let's construct a property. So I'm trying to call a function like prop name from arguments. So with the arguments, we are trying to call the prop name. So function to addition, just I'm trying to create one more function call. I will create one more function. So this function is like in this function, we'll be creating the keys. We'll create the keys in this way. So that's the reason here we are trying to call again this function. In this function, we'll try to create keys, unique keys. This function is mentioned to have a unique keys so that we can store the values with the unique keys such that next time whenever you are calling, we'll be verifying whether the key is same as in the object such that we'll be returning the value of 30. So let's do that. So here it would be same function to addition, comma arguments. So we are sending these function and these arguments here. So now the intention here is we need to do a prop. I mean, you can keep any of the variables. Prop name. Ideally, I'm trying to create the property names here. I mean, property key. I'm trying to construct the property key. So here, what I'm doing is like I will do a prop key dot. I'm trying to concatenate the here. If you observe, the key should be unique. For that, what we have used is the function name, a delimiter, and the arguments. So that is what we are trying to do here. So for that, we need to do this. I mean, here in this function to addition, we'll be having addition function reference. So if I tell reference dot name, I will be getting the name. In this case, it would be addition. So I'm trying to concatenate that with the arguments. So when I write this line, what happens? It will give an array like this: addition, comma 10, comma 20. This is what we are going to get. So we'll keep that in the property prop key here. So later we need to return back this unique key to where it is calling. So prop key dot join. I'm trying to join these with the delimiter pipe. So in this case, what it happens, this array will be converting into a string like this: addition, pipe 10, pipe 20. Why we are doing all these things is to generate a unique key. This is to generate a unique key so that you can save its unique value in the memory cache. So here we have called this prop name from arguments. Here why? We have taken the function reference and arguments. We are trying to concatenate this function reference dot name. It gives the name of the addition, and arguments. It returns an array like this. Here we are trying to join it with the delimiter. So this would be written back. So here in the prop name, we'll have this one. So later on, we'll in this function, when we call this in this function, we'll use that as a prop name. In the property name, we'll use that prop name. If that property is exist in this memo function, if it exists, this property is exist, we can, if it is not exist, we need to call and do the computation. As we wrote the comment here, we need to call and we need to do the computation. For that, then you are deciding to call the function. So now call the function with the required arguments. So you have called this because the value we are looking into is not present in the memory. So you're calling the function, this sum function, and you're getting the result back. So now at least you need to save that in the memory cache. So now you're going to save that in a memory cache with the prop name. So with the same prop name, you are going to save this. So if it is first time you're calling this function and it will store the value. Now in this property, it will be storing like this. So you can return the result of memo catch prop name. So it will return the result of 30 because we are accessing this object with the key. So if you access the object with this key, it will return back this 30 value. So if it is value is exist, so already if it is exist in the memory, you can return that from the cache. So that's simple. Yep. So instead writing it two times, if the value is not there in the memory cache, you're trying to call that function, doing some computation. And once the value of this computation is returned from this method, you are storing that in the cache. And that cached value is returned back. So for the first function call, this will happen. For the second function call, you are trying to call the else. You will be getting the value from the cache. So instead writing two return statements in if and else, we can omit one. I'm trying to delete one and I will push that to the end of the function. So in this way, we can optimize. If this case happens or if this case happens, we're going to return the memory value property. Fine. Here, what happened here? So we have taken the memorize function reference and we are trying to send two parameters here which will go to this. The reference of this function will go here. And now here we are using a closure functions where this closure function receives the second arguments like this. And later on, here we are trying to find an unique property, we are unique key. We are constructing a unique key like this such that for next inputs, we will verify whether the same key is there or not. Why we are constructing the unique key means in case if in future the we'll get like some values, if you are not constructing the unique key for the different values also, the function may feel that it is a different value and it will return from the cache. That should not happen. So that's the reason we are constructing our own key. In this way, there won't be any ambiguities in the result. So let's check it. Yeah. So the first 30 came from the real execution. So here the computation was done. And in the next execution, we are getting it from cache 30. So that is what happened here. So we can take a number of inputs here. So let me take one more input. I will take different inputs like I will give 2020. And here I will give again 2020. Let's see what happens. So even first I get 30, 40 from cache 30 from cache 30. So see, we are calling the function with two different parameters, even though our function is capable of storing all the inputs. So not just one recently called function, it will store n number of functions like this. You can give here 30, And again, I will give the same function in the last. See, I'm calling this multiple times. So the first three functions are unique time. So it means first three will be called uniquely. So rest and later those values should be stored in this memorize object. This is a cache. In our case, this is a cache. So this will catch all these values and the keys. It will generate the keys and the values. And then we are calling the same functions with the same parameters inputs. Then it will not execute this function part. It will directly pick from the memory, I mean from this memory object, and it will show that. So that's all about this memoization in JavaScript. Hope you understand the video. Thanks for watching.